Okay. Fine. Okay, so that was, sorry for that, but it was for our purposes. We wanted, because this we always record them for purposes of people who are on other, to be able to have all this. So I was saying that we finished when we were looking at comparative. So today we want to push ourselves to something else, which is, I gave, I think, an example, which I wanted the students to do, but a number of you did not do the work, which is very bad, because you are not good students, because you don't want to, for us to look at the work, but it's okay. So we drew up the comparative bar graph, and I said that is how it looks like. On this, you give the values, and here you give the years, and therefore the title must be there. So let's introduce ourselves today to what we call as a compound. Sometimes people call it cumulative bar or line graph. When I say bar graph, bars are the ones we use to construct. If they are line graphs, are the ones we use to construct. Now, even before we talk about this, I want a student to understand what we call as a compound or a cumulative bar or line graph. In the real sense of understanding a compound, it is something that keeps adding on in a cumulative way. You have something, a bar is constructed in an aspect that you will have values adding on top of the other. So if not, you cannot draw a compound or a cumulative line graph or bar graph without you having the cumulative table. So students must know that when you have been given data, and the data wants you to come up with a compound or a cumulative line graph or bar graph, it must be to you that you should be able to construct or to draw a cumulative table, which cumulative table is actually helping you to make additions of the information. I wanted to first clear that before we even go through this. So now, after us going through this, then now I want to bring out onto this. We are saying that the compound, just a minute, the compound or the cumulative line graph, this is a group of graphs that involves portraying of data in a cumulative way. Cumulative means in an additional way, you get one to the other to the other. So the reporting or the way you are going to plot is on top of the other. That's why I'm saying that the highest line may be the highest total of values given. We are saying compound line graphs have their lines and they never cross each other. And we are saying that if this happens, then the graphs become wrong. Why? Because these lines must be portraying information which is added to the other. So in one way or the other, you will never see lines having issues that they are crossing, because you have already you are supposed to have a table, which table must guide you and help you on how to get the next figures. Thus, lines, segments, separate the component parts of the sum total of what is given in a product. So in a drawing of a line graph or a bar graph, or a compound line graph, one of the things is that the construction, you will need to have a cumulative total. You have to add up those cumulative, you have to add up those totals to be able to have how they move from one to another. That's what we are calling as cumulative. They keep, you have one, add it to another one to give you the total. Add it to another one, give you the total. Add it to another one, give you the total. Like we shall go through them and something of the kind. And therefore, we are saying that which represent the progressive total of the values given. Then we are supposed to determine the scale. For those of you we started with, I gave you a simple method of how do you determine the scale. You look for the highest value, divide it with the number of total you want to give. However, for compound or cumulative, sometimes you may be given when it is in percentages. And therefore, if it is in percentage, almost the scale is determined for you that it will total from 0 to 100. So you will only need 10 units on your vertical axis. Then we are suggesting that it is important to start with the biggest value. you are supposed to start with the biggest value for you to be much more clear on what you are saying and the rest. Otherwise, if you start with the smallest value, then you may have questions of how you relate with some of these things. Then the other one is that you superimpose the other lines above the first line, starting with the 0 or the baseline. What we are referring to is that superimpose is that a line you have constructed, you put it on top of the other one. But I'm going to show this in the demonstration here. So you superimpose. Superimposing is like putting something that exists and you put it on top, or you put it on odd. That's what we call as superimpose. Then use the colors to shade the components, or sometimes the writings may be done on them, but it is not always advisable. It is better to use the colors. And that is why I told you that it is important to have colors in this paper. Lines are attached to the vertical axis. You remember, for line graphs, we said the lines are not attached, but these ones must reach all the two axes. For example, all the vertical sides of the graph. And then lines must not cross each other, since plotting depends on cumulative totals. That is basically what we look at. So we are saying one of the way of doing that is that you should be able to draw a cumulative table. We are going to look at this. You draw a table by adding one value to another to be able to give you the following until when you go up to the last. If the values that are given are in percentages, then those percentages must add up to 100. So that's what I'm saying, showing the progressive figures given. Then look for the convenient scale, assuming it is not in value, in percentages. Then you must look for the convenient scale. And I told you how you get the convenient scale. Then draw the lines designating the variations of a given area. We have said shade or color between one graph line, if they are lines or bars. Then show the writings, or some writings can be added on triangle. Where necessary, use a key. Where necessary, use a key. And we shall try to go through this. Now, let's go through the practical work. Please, I want you to be very attentive and also be very keen to understanding that some of these things you can only know them from here. Once you miss out on a procedure of understanding, you have missed out on that procedure or on that method in this. So this one is a table showing the distribution of working population in the Netherlands in percentages. And they have already given us the figures. For example, on this side, they have given us what? Years. And then here we have agriculture and fisheries. These ones are the different what? Working, the population where people are working. In other words, these are like sectors or departments, which we look at in paper 2 on the other side. And then these figures are given in percentages, these ones. So what I was referring to is that if we are given such a figure or such data that is given here, then you must go ahead and construct what we call as a cumulative table. Which cumulative table is this one? So now we are looking at a situation that you are having years, and I've represented these years by here. But I want to come up with something that is going to guide me, because the graph I want to draw must total, or must, I'm going to draw it in percentages, and it is coming from 1 or 0 up to 100. But how do I get those segments? How do I get those blocks that are there? I am first of all going to add this. So in this aspect, we are getting one for 1890, which is this. But because of the figure being this, we are going to go like this. We are going to go the horizontal way, not the vertical. Because the representation we want is the year 1890. We want to know what is represented for agricultural fisheries in 1890. What of 1920? What of 1960? And what of 1967? So in other words, when you get these, we are not going to add them like this. We are going to add them like this, horizontally. So for us to be able to get the cumulative table is that we shall write here as a cumulative table, because in the marking we must have it, and it must be there. So we are going to get 33 as our initial one for agriculture. When we get 33 plus 32, we get 65. 65 plus 16, we shall get 81. 81 plus 19, we shall get 100. We shall go to the next year. I hope we are together. I've said we are adding 33 plus 32 plus 16 plus 19. That should be able to give us 100. This is what I've done. Now what you are calling as cumulative is this figure, 33. When you add it to 32, it gives us 65. So it has cumulated, it has added up. So 65, we add on 16 to get 81. 81, we add on 19 to get 100. It means that our graph we are going to draw is going to total from 0, but our first segment, our first marking, all of plotting is going to be at 33. The next one, 65. The next one, 81. And the last one, 100. So we shall do that to also 1920, where we shall add, for example, 1920 is this 24, our initial here. When we add 24 plus 32, we get 63. 63 plus 21, we get 84. 84 plus 16, we have 100. We shall have done with that one. We go to now 1963, which is this. We're having our initial one as 11, and 11 is here. When you get 11 plus 42, you will have 53, which is this. 53 plus 23, you will have 76. 76 plus 24, you will have 100. Then our last one is 1967, which is 8. When we get 8 plus 42, we shall have 50. 50 plus 24, we shall have 74. 74 plus 26, we shall have 100. Sorry, there is something that is here. It's supposed to be 100, not 10. So what we are referring to as a cumulative table, it is this one here. And every student who is going to do and who is going to work out anything of a compound, or what we call as a cumulative or a bar graph, you must have this table created, which we call as a cumulative table. If you don't give us the cumulative table, then we cannot mark the work. Why? Because we don't know. It is this cumulative table you are going to use to plot, not these figures. Are we together? I think we have known how we get onto the cumulative table and how we add them. Now, I want to help you to warn students that one of the key things that you can have is failing to have the order. If they have told you that these figures are in percentages, it means that when you total this, it should be able to give you 100. So if it gives you figures and the figures are more, it means it is wrong. It can be a possibility that a student can just decide to add it like this, horizontally. But in the real sense, you're supposed to add it to give us to 100. Now, we are going to use the cumulative table to be able to have something that happens. I want to know whether there are questions here before we can continue. Any question?
No.
No question. I'm saying Shakira. Shakira, is it Shakira? There is someone called Shakira. Please unmute yourself and share with us what you have. If not, put down your hand. Is Shakira with us? Okay. Maybe he just forgot. So that is how we have reached. Please, all of this working, you making a cumulative table helps you and it earns you a mark because it is the one we are going to use to draw the map. Now let's go here. Now, these are bar graphs, and we are using the other work that we have been given. This work here, we are now using the cumulative. And it would mean that our first bar or a segment. What I'm calling as segment is this line here, and this one, and this one, and this one. This blue here is a segment. It represents something which is supposed to be for one. If you look at this on this side, you will see that this one is a representation of agriculture. So it is a segment that we are having. And therefore, these figures we have given for the different years, because down here we are having years, and we are like having, this is 1890, 1920, 1960, and 1976. If we go up here, this representation is 33, 24, 11, 8 is what we are representing here. So you will see that this one, 1987, is having us a representation of 33. That is what it was. If we go back here, 24 is for 20 here. 24 you will get here. Then if you go to this, that is going to give us 11. So that is 11. And then when we go to this one, it is supposed to be 8. And when we label here, it will give us 8. That is one segment. That is what we are referring to as agriculture. Yes, please.
They are distracting us.
Yeah, sorry. Hello, Namdala. Hello. Yes, please. Hello. Friends, can we request there are people, please unmute yourself. There is someone who is near a fridge. I can't trace. Please unmute yourself so that we are able to give opportunity to the rest to be able to hear. Otherwise, you are getting an echo. Okay, thank you.
Unmute yourself.
Please, if you have a friend, tell him, because let's unmute yourself so that you are not able to hear your conversations. Otherwise, the rest are getting back a sound. Okay, thank you. So that is basically how we look at this. So we had started by plotting this segment. So we want now to plot the second one. And the second segment is now this. Remember, we did the first. And I told you that we get 33 plus 32 to get 65. So the second segment would be 65, 63, 53, and 50. So when we go here, we shall just add on this. So we shall go and get our 65, 63, and then 53, and then 50. So 53 is here, and then 50. So we have already got another segment, which is 2. And then we shall do the same to the third segment. And then also do the same to the fourth segment. And then our representation, this is what I said, this is the key. So this one means that this yellow here, this yellow segment is showing for others. This other one, which is like gray, is showing for trade. The red is showing for industry. And then blue is showing agriculture. So we are using a cumulative table to give this. Now, if we have constructed here, it would mean that the last figures we have will automatically be 100. You don't need to plot them. It comes like automatic. So you may not need to have everything. So that is how it will look. So my fashion here, I only wanted to demonstrate it. But remember that this one is supposed to be labeled. And those of you who remember, what are we going to put here? Percentage of workers in, or workers in percentages. And then this one, we shall label it as years. Yeah. Remember, on this side, you will also be able to make this graph and also have this labeling. So at the top of it, this is going to be like 100%. And that is basically how it will look like. Remember that a title is important because it is the one. So a compound bar graph showing the distribution of workers' population in percentage in Netherlands. That is what you are supposed to work out. Now, there are cases where you may also be given the same information or the same data, and they ask you to construct a line graph. The procedure is the same. You will still need the cumulative table. The only difference is that you will now use lines. So how is it going to be? This is how it is going to be. You will label up. Of course, here you have your years. I remember 1890, and the others here. So you will go on labeling. Like here, you label here, you label here, and label here. And join this line until when it goes. Then you will shade it. Mine is already shaded. But ideally, it would be that I have to join these points I have marked on here, and then I'm able to shade this. Now, because we have had this, our second shading, our first shading on 1890 is 33. On 1920 is 24. On 1960 is 11. On 1967 is 8. When I go to shade the second one, I will shade 60. I will plot at 65, 63, 53, and 50. So that is what I will do here. I will just come and shade. Where do I have 65? Maybe around there, like that, and then maybe 50. And I will join this, a line like that. And after joining, I will shade it. I will do the same to now also this one, 81, 84, 76, and 74. I will also join them as they are, 81, 86, 74, and then and I join. Now, the other aspect that comes last, it becomes automatic. You don't need to measure because you know that for the next one, if we're looking at this, it is already giving us what? 100. As the last digit or the last segment or the last line. So when we come here, we shall just shade this. And you will ideally see that this one totals. Of course, the heading, you don't forget it. It is the same heading we use now, but this one is a compound line graph. Onto this side, we have already given what? The key. Please note it that the key must be given on the same page. Don't carry the key and put it on the second page. No, the page where you have worked the work, where that particular work, where the graph is where the key should be. Then on this side, you should be able to give us to write, which we have referred to as labeling. So you label and also here label. Here they have not put the years, but you are supposed to put the years like we did here. And even on this side, you are supposed to label this and also label. When I say label this, you give this in workers in percentage. Then here is years. So you will do the same to this. Now, those are like my workout. This is just my textbook or pamphlet I use to help. That is how it would look like if you do using your hand. I mean, your pencil and the rest, it will look like that. It is the same like the other, but I wanted to differentiate it so that you are able to see. This one was the line graph, the compound line graph, and this is the compound bar graph. So these ones are the segments. When you look at this, you'll able to be able to know that this area here is represented here as agriculture and furniture. This area here is represented here as industry and mining. This area here is represented here as trade and transport. And then the last one is the others. So basically, that is what we want to work out. Now, let's try to look at the advantages and the disadvantages. One is that when it comes to advantages of this is that the totals are shown properly. When you look at, yes, please.
Teacher,
yes.
Do you label on both the sides of the vertical axis? Do you label also on the other side?
No, so long as you have labeled on this one means the same. It is the same thing. So you only label on one.
Master,
Okay.
Yes.
do I draw the line graph with a ruler or with my free hands?
You mean this one here?
Yes.
It is important you draw it with a ruler because we shall want to know how these go, and they should actually be neat and smart. So you get a ruler and put them here, draw that and go. So it's supposed to be a ruler, please. Any other question? Someone has asked, I think we have answered that. Any other more about compound graph? For both the sides, we have answered. Excuse me, sir, those labels of percentages, very important. You label both, no?
Excuse me.
Yes. You are
Excuse
not?
me.
You are not? Hello? Hello?
Excuse me. Excuse me.
Yes.
The graph. What if the graph doesn't? Okay. What if it doesn't require the percentages? What? Okay. How can you do the cumulative? Okay, the cumulative table. How can you make it?
The cumulative table remains the same. If the data or the information that has been given you, it is not in the cumulative, I mean in the percentages, you will still get it. You will get the figures that you have been given here and add it. And what the totals that it gives you, you just draw the graph as it is. For example, instead of it joining maybe up to 100%, it can join up to here. It is okay if it is in absolute values, like it's not in percentages. You still have to use the other method of doing the cumulative table, because it is the cumulative table which guides us on how we shall draw. The essence of the cumulative table is to help us on making the addition so that we are able to know what we plot first and second and third and fourth and fifth, even if they have given you 8, but rarely will they give you a figure to that. Please, some of this work that is given to you, like for example, if it is UNEB, it is work which is worked out. It's not that they make mistakes. Rarely would do UNEB make a mistake. And if it does, it will send the information through your head teacher that maybe there was a mistake in this question, but usually it's not. So to answer the question, if it is not in percentages, please make the cumulative table and draw the curve, the line, or the bar graph as they are supposed to be. Any other question?
Master, how do you plot those many values?
How do we plot the what?
The many values, like when they are in millions.
When they are what?
When they are very many and complicated.
For example, are you meaning many in value? For example, here they give you many.
Like on 1890, in agriculture, they give you 1 million.
Okay. If they give you 1 million,
when
then
the values
yes, I have got your question. For example, if they give you here the values and these values are like 1 million, then this representation, we shall only take the 3 zeros or the 4 zeros away. Those representation will be represented here in the top of the what? Of the table. So when you give, instead of saying this, then you will put here, you will reduce those zeros and represent them in the heading when you are giving the what? The title here. If it is a million, you remember million has 6 zeros. So you can reduce the 3 to only come to 1,000. So those ones, when you are putting here, you will put a compound bar graph showing distribution of work in what you will put here in 0, 0, 0. Meaning that here you are only representing 1,000, but there are others which are another 1,000, which gives us a figure of 1,000,000. That is how you give it. Any other question?
Excuse me.
Yes.
It's like what in percentages?
I beg your
Will
pardon?
if the values are not in percentages, will they still add up to the same? Will they still, the totals, will they be the same?
No, the totals cannot be adding up to 100. The totals, if they are in that's what we call as absolute values. If they are in row marker, let's say from 1,000 to 100 or to 1,000, and it's not in percentages, the totals will add up to that figure. But it is the cumulative table which will give us the last figure here. Instead of it now being 100, assuming here they have given us 330. They have given us maybe 330, 320, maybe 160, and 190. It means we shall get 330 plus 320 plus 160 plus 190 to get 10,000. So it means that the totals here are going to be 1,000. If they are the same also onto this one, then you will also add them. So irrespective, the graph may not have to total up to 100. If they are in absolute value, it can be a graph which can be like this. You will find out that this graph may not total up to here. It may just be even crooked like this. I wish I had the, I don't know whether time can allow. I would edit this. I'm not able now. But it would not be able to give us this. Just a minute. Let me see if I can. How do I get this? If I can have this off, then you'd see what I'm trying to mean in this. Oh, no.
Mr. Kagoye?
Yes, please.
Mr. Kagoye? And we are remaining with 15 minutes for paper 2, then at 3:40.
Okay, fine.
3:40, we have Mr. Ambasan is coming back. Okay. So we are going to have a break, just a few minutes, then we come back at 3:40 for paper.
Fine, it is okay. Let's see. I hope you are able to see my screen. Are you able? No.
No.
Yes, we can.
No.
You are not able?
No, we are not.
Okay, let me see. Look at Okay, are you able to see?
Yes, teacher.
Yes.
Fine. So if it were like this, we may not be having a lot of time, but let me just try to explain, maybe guide us. It can be like something like this. Can I have this data? For example, bar graphs, but this one. Okay, are you looking at something like that? Are you able to see that?
Yeah.
Yes.
Yeah, it can be something which is like that. Well, I may not have the time because the time we have, but these categories we can rename them, and this can be like years, and on this side it is there. So it is like it is adding up, and this one is also having another figure, and this one is also having another figure. But it is not necessarily that it is in percentages. So that is how it will look. It can still be possible that even this can change. For example, if I edited this, you will find out that assuming I gave it 5.7, and I entered it, you will find out that this can keep changing depending on how the figures are. If I changed this, can I change this later? Let's say this is series, maybe one that is blue. Let's say 1.1, 2, 3. You can now see that this one is even has changed. Are we together? So it may not necessarily be in absolute value. So that is what we basically look at. Okay. So let me now just finish up. Yes.
Teacher,
Yes, please.
can you give us an exercise?
I want to give you exercise here. I want to give you exercise.
Excuse me, sir.
Yes.
Teacher, is it a must?
I was not able to hear you. Is it a must?
Is it a must to change the values to percentages?
No, I wouldn't advise you to change the values to percentages. That will take a lot of time. Remember, at this level, we are saying that time is part of examination. So just use the absolute values. If the values are very high, you do it by reducing the 2 zeros, and those 2 zeros are represented in the what? The table. Are we together? So I wanted to give you like this one. You can take and work out for me this one. Do for me out this worker here.
Okay.
If you want more data, I can still give you. But this one, for example, you're having exports. This one is for imports. This is for exports. This is for imports. This is for exports. Are we together?
Yes.
So we can try to do out this work. I can even give you another one. But if you have a screen, if you are doing some screenshot, this is a question of 1998.
How do I send you my work?
Send by email. I want to give you my email. That one can be very quick and very easy. My email is, I'm putting it in the chat room. Hello? Yes, please. That is my email. And in case you just have a challenge, that is my number, my WhatsApp number. We can always.
Mr. Kagwe,
Yes, please.
I think the number you have sent it to someone who's inbox, not on everyone.
Oh, sorry, I'm not on chat.
Because we are not seeing the number and the email. Just tap on where you are sending and you tap on everyone in the meeting.
Okay, I get you. Everyone, okay. Charles.
Sir,
Yes, email.
like what I was saying, I was asking.
Yes.
And the part of disadvantages and advantages, where am I, like, when I'm putting them down, should I explain them or I just outline them?
No, please, we don't explain those. We just outline them as they are.
Okay, sir.
You just outline them as they are. It serves, it summarizes data. It is easy to interpret. There is no explanation. They are just outlines. That's all. So friends,
Teacher.
I've tried to send my number. You can't be able to see my number.
Can-
Okay.
Yeah, able to see. Yeah.
You are able to see it.
Yes.
Yeah.
Fine. So
So
I
the
just
question
wanted,
is
the question is,
The question.
incomplete.
no, down here is draw a bar graph. Draw a bar graph to represent. If you so want also, you can even visit the question bank, because I extracted it from there, 1998. Check also in 2022, 2002, they also brought a question about compound, and I think also 94.
How about if they say the trade pattern?
If they
say trade pattern like in Brazil or Japan?
I'm not getting your question. If they say the trade patterns,
Yeah, like in Brazil or Japan.
I'm not getting the question. If they said in trade patterns in
Identify
Brazil,
the trade pattern. Identify the
Oh.
trade pattern in.
That is the section. That is section C of that question, 1998.
Yes.
Now, when they say identify the trade patterns, is like look at the two, Brazil and the Japan, and give us, because this graph is showing exports and imports. So they are like saying, what are these changes that are coming? Are they low? Are they high? Are they relative? It is the same thing we look at like in the trend. They have asked questions about trend. Give the trend of this. When they ask of the patterns, is like they want to know what is there that is common in all of these two, the imports and the exports, in terms of when they export in foodstuffs and in minerals, in chemical, do they have something that is in line, especially in these figures? If you look at the figures, for example, for exports or imports for Brazil, and you look at the imports, is there any similarity? Is there anything in common that these people do? If it is not, then you want to give us, and you will say, this one is export is high compared to the other one, something like that. So you should be able to look at this. Sometimes they specify in foods or in foodstuffs, or they specify in a particular year, something of that kind. Basically, I think that one. So I just wanted to take this, please, these advantages and the disadvantages, you can read them. If you have a screenshot, you can take a screenshot of the disadvantages. They involve a lot of calculation before drawing. Like one of the example, you must have drawn a cumulative table. They require, there is error missing here. They require a lot of time to draw as compared to simple graphs, which you have seen. Then individual values are not easy to read from the graph because of accumulating figures. Remember when we were working out on these ones, is that we were not able, we only used this. In the cumulative, but you cannot be able to see this. You only see this and 65, but you cannot know that this is now 33 adding on to this one. So that's what we are saying as the disadvantage, that it becomes hard. Then the advantages, they're also there. The totals are shown properly. They have a good visual impression if well drawn. They can portray more detailed data as compared to simple graphs. And they show a wide range of items as compared to the other one. I have been asked that we shall, I think, I don't know whether we still have time, but I wanted you to do more of the reading and do more of the practice. Statistics for any student to excel and have marks. And I told you that if you want to excel in this paper, you need to get at least 23 and above on this number. And it is very possible. One tactic is to do practice. Read, get more questions, do exercise, practice. These things are going to be very quick for you to be able, because the more time you interact, the more time you get to know all of these ones. So the next time we meet, I want you to go and read about divergent, all the divergence line and bar graphs. That is what we shall work out on, unless if you have questions. Any
Master,
question?
when are you meeting again? Yes.
We have a lesson.
Master.
After this lesson, you have paper 3. Then on Friday, you will have paper 1. Now, on Friday, we shall confirm whether paper 3 goes on Monday or Mr. Ambasani, the next facilitator, is going to give us a show up of whether paper 3's show will be shifted to Monday, and then paper 2 remains on Wednesday. That one we are going to confirm, and through the WhatsApp and the messages, we will be able to have all this. Otherwise, for paper 2, you shall meet on Wednesday next week. Please, like I have said, if you have any challenge, reach me out on those numbers and also on the email, and then we see. If you want even more work, more data to practice, send me a text. I can always send you work. I had something I even wanted to give you more work so that it keeps you busy. Maybe if I have some work here, let me just check quickly and then see if I can get out before we can even, so that you have something that keeps you in statistics for this, for this time. Let me see, can I have my, oh.
Thank you very much for the lesson.
It's a pleasure. I'm just trying to see if I can get work, more work for you. Oh, where is my desktop? Okay, maybe for time I may not be able because I did not prepare. No? Yes.
Excuse me.
Yes, please.
Like in 2002, did they say assess the contribution? Now, if you're assessing a contribution, do you explain or you just outline?
Assessing a contribution in section B? Is it a statistic number or it is in section? Is it in section A or section B?
Section A, statistic.
Did they give the mark?
They didn't, but the question is in 2002.
2002. That is your name question, right?
Yes.
Can you read it?
Assess the contribution of the copper mining industry to the development of any one country given in the table. The countries are given in the table. Now my question is, if you're assessing the contributions, do you explain or you outline just the contributions?
No, the reason here you are supposed to give the contributions, you are supposed to outline them. I mean, you are supposed to explain them. You give one by one like you would give. However, as per today, UNEB will always give the mark. 2002, UNEB was not mentioning the mark. That is why it brought in the aspect of mark. So if they say marks, you will find out that on this question, they gave it like 10 marks. Question A, like drawing the map, was like 8 marks for drawing. Part B, identifying the list, was 2. And then the other one, we are supposed to now look at the aspect, the part B part of it. So if they say assess and they have given it 10 marks, it means like it is like a question like of section B, and you are supposed to give all of them. You don't summarize, you give in full.
Okay, thank you, teacher. Then, teacher, you didn't mention anything to do with scales. Are they relevant or they are necessary?
Scales for this? No, the scales we worked out. I told you when we started, maybe you were not around. I told you when we started that some of those things like scales, they are important. Key is important. And I don't want to talk about them. Not that they are not necessary, but I know that every student, I remember explaining to you that you are supposed to give the scale for every method, especially with graphs, except with when we go to like spheres, tubes, and those ones where you may not need to show. But for these ones, the scale is you must give the vertical scale and the horizontal scale if they are necessary.
Teacher.
Yes, please.
Teacher.
I can get you.
enclose. Hello.
Yes, please go
Hello,
ahead.
teacher.
Yes.
Teacher. Do we enclose after getting the real scale at the top of the graph?
I want to know what you are meaning by enclosing, because I may not be getting you well. Are you meaning that on the graph, when you are having a graph like this, are you meaning to enclose here? This graph on this both sides must be closed. Yes, this side must be closed. And I encourage that you also label it for purposes of you not looking this side. It is supposed to be enclosed, please. Okay, so I want to think that you have been able to enjoy the lesson. Please, let's catch ourselves next Saturday, but we are breaking shortly for the next lesson to go on. I think which will shortly start in a few minutes. So just have yourself a break, and then you will. I need to ask Mr. Namdala whether you are breaking or they are just going straight. Mr. Namdala, are you online?
I'm online. We are breaking, and we start at 3:40. At 3:40. So I'm going to end the meeting so that people can rest their gadgets for a few minutes. Then we come back.
Okay, fine.
For paper 2.
Okay.
Which one are you coming with?
Paper 3.
Paper 2.
Paper 3.
Paper 3, sorry. Paper 3.
Okay.
Is it the same meeting code?
Yes,
yeah, it's the same.
Okay.
Just at exactly 3:40, you tap. The room is going to be open.
Which subject?
Geography.
We're doing only geography.
Okay. Thank you.
Okay.
Thank you for attending the lesson.
A pleasure.
Well,